Howdy, this is the solutions video for Calculus Homework 1.3a, section 1.3a, and is page 64 is where it starts 5 through 35 odd. Alright, most of these are plug-in limits, so hopefully you found most of this to be easy. I got through number 27 on the board. So number 5, we're just going to plug in 4 to x squared and get 16. Number 7, we plug in 0 for x, so you'd have 0 minus 1, negative 1. Number 9, we're going to plug in 2. Be careful of that negative sign there, so that'd be 2 squared is 4. Negative 4 plus 2 minus 2 would be negative 4. All right, number 11, plug in 3 into this square root function, have the square root of 4, which is 2. Number 13, plug in negative 4, so that would be negative 4 plus 3, which is negative 1. Got to square it. That'll give you 1. All right, plug in 2 for number 15 into x. That's 1/2. Easy peasy. Number 7, plug in negative 1. You'd have negative 1 squared plus 1 over negative 1. Negative 1 squared is 1. 1 plus 1 is 2 over negative 1. That'd be negative 2. Number 19, that's just going to be sine of pi over 2. Look at your unit circle. The sine of pi over 2 is 1. Number 21, that's going to be the cosine of pi on your unit circle. Look at that. The cosine of pi, or 180 degrees, is negative 1. Number 23, you're going to plug in 0. That's secant of 0. Well, let's look at what is the cosine of 0. And that is 1, flip 1, and you get 1. All right, we're going to plug 5 pi over 6. Sine of 5 pi over 6, just consult your unit circle. Remember, that's going to be in quadrant 2. Sine is the second value in the parentheses, and that's 1/2. And then number 27, we take the limit as x approaches 3 of tangent of pi x over 4. That's the tangent of 3 pi over 4. Remember, tangent is sine over cosine. So we can look up the sine of 3 pi over 4. That's root 2 over 2. Cosine of 3 pi over 4 is negative root 2 over 2. So that's going to reduce down to negative 1. All right. So hopefully you didn't have any trouble with those. If you did make a mistake, hopefully it's just a minor plug-in type mistake. But you don't want to miss anything like these on the test, because we don't, you might only get one plug-in limit on the test. Okay, now let's look at number 29. So 29 says we have the limit as x approaches c of f of x is equal to 2, and the limit as x approaches c of g of x is equal to 3. So part A, we want to find the limit as x approaches c of 5 times g of x. That's just going to be 5 times 3, which is 15. Part B, limit as x approaches c of f of x plus g of x. That's just going to be 2 plus 3, which is 5. Part C, limit as x approaches c of f of x times g of x. So we did an example pretty much just like this with different numbers. That's going to be 2 times 3, which is 6. And then finally D, limit as x approaches c. It's probably f of x over g of x. Yes, it is. So it's going to be 2 over 3. All right, 29, not too bad. I think that 31 is really similar. And hopefully you're not even having to watch this, you're just fast forwarding through this. So 31, we have the limit as x approaches c of f of x cubed. Oh, excuse me. Of f of x equals 4. All right, so there's no g of x here, so A, we want to find the limit as x approaches c of f of x all cubed. So it's going to be 4 cubed, right? So 4 cubed is 64. And then B, we have the limit as x approaches c of the square root of f of x, square root of 4, which is 2. In part C, the limit as x approaches c of 3 times f of x. So that's going to be 3 times 4, which is 12. Finally, the limit as x approaches c of f of x to the 3/2. It's going to be 4 to the 3/2. So that's like taking the square root of 4, put that square root of 4, and then cubing the whole thing. So that's 2 cubed, which is 8. Right, so 64, 2, 12, and 8 for number 31. And let's do 35 when we finish with this video. Okay, 35, we're going to look at the graph. So A says find the limit as x approaches 1 of g of x. B says find the limit as x approaches -1 of g of x. So we're just going to read the graph on those two. And then the third part, we're going to find two functions that agree at all but one point. Okay, let's look at the graph here on number 35. So where do our hands come together as x approaches 1? So from the left, here's 1. From the right, the y value is 2 for part A as x approaches 1. As x approaches -1, coming from the left, coming from the right, as x approaches -1, the y value is 0. So 2 and 0. Now the more interesting part is let's find the function that agrees at all but one point. And on this one you have to remember a little bit of algebra, a little bit of factoring. So let's say we have x cubed minus x over x minus 1. So the question is asking, is there another function that is exactly the same graph at that as that, except maybe it's not the same at one point, okay? Because we know this one's undefined at x equals 1. Okay, so let's factor an x out of the top. So we've got an x, and we'd have x squared minus 1 over x minus 1. And here you say, well, you cannot cancel that x over x. I hope you remember that from Algebra 2 and from Pre-Cal. This x is attached to that -1, so you can't cancel. We can factor. This is the difference of two perfect squares. So we'd have x times x plus 1 times x minus 1. All right. A is x, remember? B is 1. The difference of two perfect squares, which x and 1 are here, is x plus 1 times x minus 1 over x minus 1. So I'll remind you of those factoring rules as we need them. And now you can cancel that out as long as x does not equal 1. So there's that one point that they don't agree. And then you'd have x times x plus 1, which that might be the answer in the back of the book, or maybe they distribute and say it's x squared plus x. That's the same thing. So That function matches this function. It's the exact same graph, except this graph has a hole at 1 because it's undefined at 1. And the graphs of these are not undefined anywhere. All right, that does it for this homework solution video. I will talk to you next video.